All right, so hello everybody. I'm going to continue from the previous video where we talked about binomial expansion. Okay, so in the previous video, I explained how to go about it and give some examples. So we're just going to continue answering questions. So just to recap, remember that so we have, let's say, a plus b raised to power n. Then that will be the summation. So starting from r equals 0 and stop at n. Okay, and then we have, now we can write it like this, or we can write it like this, n c r, just shows combination. Okay, then multiplied by a raised to power n minus r, then b raised to power r, and n is usually the exponent. Okay, that's it here. And r generally starts from 0. R usually starts from 0. Okay, so that's just by the way. Let's continue answering some questions. Okay, so sorry about that. So let me get the next question. This is actually more a bit interesting. Okay. Right now, find the constant term in the binomial expansion 2x minus 1 over x raised to power 8. Now this might seem this might seem difficult, but it's not really that. Let's say it's medium. It's medium. So find the constant term. So what's the constant term? So it's like the term that has no, let me say, letter attached to it. Okay, the constant term. That's the term that has no letter attached to it. So example, we can have 11, 9, just numbers, just number 7. And then we have the opposite, which would be the variable term, or just call it like the variable. Okay, has a letter attached to it. Okay, like 2x, 3x, 11x. So the values would change depending on the values of x. Now, they told us to find a constant term. Okay. Now, in a binomial expansion, for us to get the constant term, okay, now, in situations where we have something like this, in a lot of, let's say we have something like x plus 3 raised to power, let's say 2. Okay, so most of the time, like in situations like this, the constant term is usually the last term because, you're just squaring this, you're raising this term to a power. So usually the last term, okay? But now in this situation, both carry an x. Okay, we have x here, we have x here. So it means the last term cannot be the constant term, or is most likely not the constant term. So how do we go about it? Okay, now for us to get the constant term, okay, so it means that there's no x attached to it, right? X attached. So it means that at some point we're going to have x raised to power 0, which is equal to 1. Okay, because x raised to power 0 is 1. So let's say if we say 11 times x raised to power 0, x raised to power 0 is 1. That's something as 11. So we have to find the situation where x will be equal to, so we have to find a situation where we get x raised to power 0, right? So how do we do this? We go back to the fourth formula. Let me just like to do this. So we have r equals 0 and ncr. So a n minus r, b r. Okay, so our first term is 2x. Okay, our first term is 2x. Let's see. So we have to find r first. Okay, so let's focus on this part first. Our first term is 2x. Okay, and then 8 minus r times. Now, 1 over x is the same thing as x raised to power minus 1. Okay, so x raised to power minus 1 r. So we want it to be equal to or 0. Okay, so we just want a situation where the power of x is equal to 0. The rest are still here, like the HCR is still here, but let's focus our attention on trying to find a situation where x is equal to 0. All right, so if we open this, we have 8CR. Okay, open this, we have 2 raised to power 8 minus r. Okay, x raised to power 8 minus r times. So using the law of indices, we have something like this: x raised to power b becomes x raised to power a times b. Okay, so minus 1 times r becomes minus r. Okay, so we have x raised to power minus r equals x raised to power 0. Okay, so let's focus on that first. All right, so we have to find our r. So again, using the law of indices, we have a raised to power m times a raised to power n is something as a raised to power m plus n, right? All right, so we're going to have to add these powers. Okay, so we're going to have x raised to power 8 minus r, okay, plus minus r. So if we open this, we're going to have x raised to power 8 minus r. So minus r is equal to minus 2r. Okay, so it means that x raised to power 8 minus 2r equal to x raised to power 0. All right, x raised to power 0. Okay, and then so we can ignore the x now and say, okay, 8 minus 2r is equal to 0. So I think you already know the answer. So it means that 8 is equal to 2r. We'll bring it here, divide both sides by 2. Our r is 4. Okay, so it means our r is 4. And what term is that going to be? It's going to be the fifth. So where's my pen? It's going to be the fifth term, because remember, r starts from 0. So in the first term, r is 0. In the second term, r is 1. In the third term, r is 2. So in the fifth term, r will be 4. So this constant will happen in the fifth term. Let's also put the values. Okay, we have to put the values here. All right, let's not ignore this one. So we have 8c, what's our r4? Okay, times 2 raised to power 8 minus 4. Let's just input everything. Let's just focus on this concept, because we already know that the rest is just x raised to power 0, right? So let's do the calculator. 8c4. So I got 70, right? Times. So 8 minus 4 is 4. Then 2 raised to power 4 will give us 16. So we'll have 70 times 16. So our constant will be 70 times 16, which is 1120. That's 1120, or 1120. Okay, so this is our constant, and it is the fifth term. Okay, so let me go back there. So the constant value, or the constant term, is 1120. Okay, the constant term here is 1120. So we can use this, it's just about being creative and knowing how to find what do you call it? How to, depending on what they ask you to find. So let me just try this. Let me use, like, and in the previous video I talked about what do you call it? Symbol lab. So let's just check to see if this is actually correct. Okay, so I'm just going to expand 2x plus 1 over x raised to power raised to power 8. I'm just going to do that and see what we get. Now, okay, so let me send you the picture of what it's the name of the let me just show you. Okay, so our constant term is 120, right? So let's see if this is actually correct. So let me come here and show you. Okay, so I just went there to expand and see. So let's see the first 1, 2, 3, 4, 5. Our fifth term is what? 120. So this is how you can do. So you don't always have to expand, depending on the term they ask you to find. Okay, you don't always have to expand. I mean, you just have to be creative. I know that for the constant to happen, then perhaps you have x raised to power 0, and then from there we can find our answer. So that tell you what is the last term. Okay, since you know, okay, let's say what is the last term now. We know that the last term will be NC. So R, which NCR. At that point, N will be equals to R, or R will be equals to N, up 8, and then we have 2x raised to power N minus R, will be 8 minus 8, dot 1 over x raised to power, that's 1 over x raised to power R, which is 8. Okay, so this becomes 0. All right, this becomes 0. But remember, there's the x here, so it's not a constant. So 8c8. So remember what I said before, NCN is always 1. Okay, so we can ignore that. So we have 1 here. Raised to power 0 here is 1 here. So we're left with 1 over x raised to power 8. And if you check it, we can see that's the last term. So it's just about being creative, like having to understand the questions. Okay, so you just have to have a way to understand the questions, and you'll be able to. So I'll stop here and I'll make another video for another question. So that if you have any question regarding this, you can let me know.